Every radio system obeys the same principle. Energy leaves a transmitter, spreads through space, and a fraction of it arrives at a receiver. The link works only if enough energy survives to be told apart from the noise. That accounting is the link budget, and it is the common language connecting orbital mechanics, antenna engineering, and communications theory. In its simplest form, received power equals transmit power plus transmit antenna gain, plus receive antenna gain, minus free space path loss, minus every other loss. 6 terms. Everything covered in this course lands on one of them. Lower orbits reduce path loss, larger phased arrays raise antenna gain. Better receivers improve sensitivity. Advanced coding lowers the signal-to-noise ratio you need in the first place. Different disciplines, one equation. The intuition is a torch. Close to the lamp, the light looks bright because the energy is concentrated in a small area. Move away, and that same energy spreads across a much larger surface, so it looks progressively weaker. Radio does exactly this. Total transmitted power stays constant, but it spreads over an expanding spherical wavefront, and the receiver only ever captures a tiny fraction of it. Now compare 2 links. In both of them, the smartphone transmits 23 decibel milliwatts. That number does not change. A terrestrial base station sits 1 or 2 kilometers away, so free space path loss at 2 gigahertz runs about 120 to 130 decibels. A D2D satellite sits 500 to 700 kilometers up, and the same calculation gives roughly 155 to 165. The difference is 30 to 40 decibels of additional loss. Sit with that number, because decibels are deceptive. 30 decibels is a factor of 1,000. 40 decibels is a factor of 10,000. So the satellite has to work with something like 1,000th of the received power, and the handset cannot help. Its transmit power is pinned by battery, heat, SAR limits, and regulation. The problem is not transmitting harder. It is recovering 30 to 40 decibels somewhere else in the system, and no single technology recovers them. The margin is assembled from many independent improvements, each worth only a few decibels. Large phased arrays raise gain by increasing effective aperture. Digital beamforming concentrates energy on transmit and collects far more of it on receive. Low noise electronics lower the receiver's noise floor. Advanced channel coding decodes reliably at lower signal-to-noise ratios. Adaptive modulation matches the rate to the channel. Careful waveform design improves synchronization. Diversity exploits independent paths in time, frequency, or space. Aperture deserves a particular mention because it scales most directly. AST Space Mobile's Blue Walker 3 demonstrated roughly 64 square meters. The commercial Bluebird Block 2 satellites report apertures approaching 223. But size alone does not close anything. Without beamforming, low noise receivers, accurate synchronization, and heavy signal processing, even an enormous antenna falls short. Put together, the chain looks like this. Start at 23 decibel milliwatts. Free space path loss removes well over 150 decibels. Atmospheric absorption, polarization mismatch, and implementation losses take more. Then the satellite starts adding aperture gain, beamforming gain, a low noise front end, and coding that tolerates a far worse signal-to-noise ratio. Individually, each contribution looks modest. Together they turn an apparently impossible link into a working cellular connection. One more distinction, and it matters. The objective is not maximum received power. It is enough headroom above receiver sensitivity to absorb fading, implementation uncertainty, and changing conditions. That leftover headroom is the link margin, and it is what actually determines whether the service is robust or merely demonstrable. To close the series, The link budget is the accounting framework of every satellite link. 2D links are 30 to 40 decibels harder to close than terrestrial ones. No single breakthrough closes that gap. It is recovered cumulatively, a few decibels at a time, and the goal is margin, not peak power. Every subsystem has to contribute its share.